Here's a question where the difficulty is trying to make sure you're done. What do I mean? It's asking how many non-congruent triangles you can make. What does non-congruent mean? First, I need to tell you what congruent means. If I have a triangle like this is congruent to, or the same as, this triangle over here. When I say this, what I mean is that I can take this one and I can turn it until it becomes that, or I could even flip it until it becomes that. Congruence actually means that the shapes are exactly the same and the lengths are exactly the same. And you can find a way to take one of them and put it on the other one so you have the same picture. Let me give another example as well. Here's another example of two congruent triangles. This one and this one. And again, what you see here is this one I could get from a rotation. Now, the question is asking, how many different triangles can I make if these two are counted as the same? These are some of the most difficult problems to do correctly because you always miss some. I want to talk about how to make sure that you don't miss any when you're doing any question like this. The first way is to try to think of a systematic way to list all of the different triangles that you could make. So let me go and try to find a good way to describe all of them. You see, if I have a triangle, the triangle lives inside some place. For example, I could say how many of the triangles live in just a 1x1 square, like this. Here I drew x's. I'm just giving a tip. Whenever you're doing a problem, it actually takes more time to draw a dot than to draw an x. That's just why I'm doing this, and this is also what I did whenever I was doing math problems before. So here is an example of what fits in a 1x1, where the entire triangle fits exactly in that. That kind of triangle appears many times. It's here, and also whenever I draw this, I also mean anything I can get by turning it. Is there any other triangle I can make that fits in 1x1? No, that's the only kind here. Well then, let's go to the next kind. The next kind of triangle is the kind that lives inside a 2x1, or one that is a width of 2 across and only a width of 1 up and down. You see, by focusing my attention on these kinds of triangles, I can try to make sure I have all of them. How can I do this? If I'm looking at this, the fact that it has to use all of these parts means that maybe I can try to separate them, categorize them by how long is the base. You see, with these sorts of triangles, when you draw it, no matter how you draw this, part of the triangle will either be on this line or on that line. But because I'm allowed to reflect or rotate, I can just have all of them with the base on this line. For example, here's one of them, a base of length 2 on this line. This is one such triangle. Let me draw some more. The next one, maybe let me continue with this idea of the base being length 2. I could also do this. But I cannot add another one which goes to the right side point because that's the same as this one. Are there any more with a base of 2? If you look at it, it's quite clear that there are no more. Let's continue. The next one I'll do is like this. Still a width of 2 units, except that now I'm going to try one where the base is only 1. If this base is 1, the fact that it actually has to live inside this area means that I have to do this. You see, because if I made it go up to here, then actually it would already be in the one which is over there. So far, what I have is that I have 1 that fits in a 1x1 and 3 that fit in this with 2 across. Okay, let's keep going. Now let's try the ones which fit in 3 across. And you see I'm thinking about this in terms of that long base. For the 3 across, let's start with the ones that are the easiest, which is the long base. And if I take the long base, I can do this, or I can do this. You can see how slowly and carefully I'm doing this, because on this sort of question, if you do it fast and wrong, you may as well not do it. So let's see. So far I have these two, but if I draw to this one, that's the same as this because I can flip. If I draw to that, it's the same also. So far I've written all the ones who have a base of 3 across. Let's continue. Here now, I will do the ones with a base of 2. And if I do a base of 2, then I also have to make sure I'm using the entire space, so I have no choice but to do this. Okay? What if I use this base of 2 instead? It would be the same. You see, I'm asking myself all of these questions to make sure I'm not missing anything. And let's see. What if the base is 1? If this base is 1, then I'm here, and I cannot only stop there. I have to go all the way across to here, or else I will not actually be in this with the width of 3 units. So it looks to me like I have 4 here and 4 there. So the answer looks like 8. Are we sure it's 8? Let's try to do it another way. I'm going to try a completely different way now, where instead of looking at where the triangle fits inside, we use this observation we've already had. And that observation is that no matter how you do it, one part of the triangle will have something along either the top row or the bottom row. So let's put it on the bottom row because I can flip. And now let's just make the list by seeing how long that base is. So let's give another screen. Here, let me draw the entire picture now. And let's start with the first category. And the first category is that there is a base which has only 1. And if this has a base of only 1, what sort of triangles can I make? I can finish this with this triangle up here, or I can finish it with this triangle up here. Notice I don't draw that other one because it's the same one. Or I can finish it with this triangle all the way over. What if I use the red base to be somewhere else? Actually, those would only give me the same kind of triangles anyway. So far here, I get 3. What if I use a base whose length is 2? If the base's length is 2, now I have a few possibilities. I could go here. I could go here in the middle, or I could go all the way to the right. So it looks like I have another 3. Okay, I'm still doing this very carefully because I'm afraid to make a mistake. And let's finish with the base 3. And now what options do I have? I can do this, or I can do this. And the other 2 are the same. So I have 2. 3 plus 3 plus 2, also 8. This makes me more confident that the answer is 8. But there's still a little bit of me that's worrying. All of these I was saying there's always a base on one of these sides. What if that's wrong? You see, that's the danger with these kinds of questions. You never know quite when you're done. So now let me show you a way that guarantees you're done by counting from the other direction. You see, whenever I'm doing these, I always find triangles. So I will never have a problem where I will find 2 identical triangles. The problem I have is, what if I didn't find one? The only way to be sure then is to say, well, how many triangles are there all together, and prove that I got them all. For this, what I want to do is I want to ask a different question. And that other question is going to be exactly what we use to solve this. The other question is going to be, if I just have these points, what if I just ask, how many triangles can I make? No more non-congruent, just how many triangles. And then what we're going to do is we're going to split them up by category and say how many of each type are there, add it all together, and if it adds the same way, then we're sure we're done. So how many triangles? To do this, this is very related to an idea which is actually covered in another course, and so I won't go deep into that. The other idea is you have to count how many ways you can pick 3 of the corners from these 8 points. So the number of triangles is actually equal to the number of ways to pick 3 points from 8 points. Almost. I can accidentally pick 3 points for which all 3 points are on the same row. So I need to subtract minus the ones for which I picked 3 points on the same row. I have 2 such lines. So I'll actually have to say minus 2 times the number of ways to pick 3 points from 4 points. 4 points because there are 4 points in each of these rows, and there are 2 rows. Again, in another course, this is covered in very great detail. And so here I'm just going to say very quickly, the way that this is done is that the first piece is 8 choose 3. The second piece is minus 2 times 4 choose 3, which I'll now calculate quickly. This is 8 times 7 times 6 over 3 times 2 times 1 minus 2 times 4. Actually, 4 choose 3 is the same as 4 choose 1. So I will just simply say this is just 4. I'm doing this quickly again because of the idea that if you haven't learned this yet, I encourage you to learn it, possibly through the other course. If you have learned this, then this actually is very easy as I'm doing it. As I cancel this, I get a very useful fact. I find that the answer to how many triangles there are altogether is 56 minus 8. And 56 minus 8 is 48. So now I have something to aim for. I know there are 48 triangles altogether. So let me go back to my 8 categories. I'll tell you how many of them are in each category, and we'll see if it adds up to 48. If it does, I'm absolutely done. So the first question is, how many of this kind are there? Well, inside one of these 1 by 1 squares, there are 4 ways that I can turn this around because of that corner. So the number of these is 4 times how many ways I can have one of these squares. Well, one of those squares, I can have this square, or this square, or this square. So there are 3 of them. So there are 4 times 3, 12 of this kind. How about this kind? Again, if I'm here, there are 4 ways to turn this. Basically, look at where the right angle is. And so, not just turn, also flip. There are 4 ways to choose the right angle. So there are 4 of these times, how many ways can I have 2 things next to each other? Well, it could be these or these. So 4 times 2, which is 8. Okay, how about this kind? For this kind, look at the flat piece. It's either on this side, or on the top on one of those 2 spots. And the rest is determined. So there are 4 of them times, how many ways can I put those 2 things here? There are 2 ways. So there are 8 of these. Over here, I only have 2 ways to make this. It's either facing up or facing down. But this location of 2 squares could be here or right next to it. So there's 2 ways there, 4. Okay, we're half done. The last one, I already am using the whole space, so I can't move it. Instead, I just ask, where's that right angle? There are 4 ways I can put that right angle down. Over here on this picture, I can think of this as there's this flat base, and it either is going to touch the top middle left or the top middle right, or it's going to be upside down. 4 of these. This one here, I have this length 2 base. It's either on this side, or on this side or this side. 4 of them. Now here, this has a length 1 base, and again, a length 1 base can be in 4 positions. Notice when I'm doing this, I'm 100% sure that I am not counting the same thing twice, which means that so far I have counted this many of the triangles. If this number equals 48, I'm 100% sure I have everything. Let's add together. 12 plus 8 is 20. 28, 32. As I keep going, 32 plus 4, 4, 4, 4. 32 plus 16. It's 48. So now I'm 100% sure I've counted everything. This question is one which actually is very easy to understand and very easy to get started in and very easy to get wrong. And I wanted to show you this sort of way of thinking so that whenever you play with a question like this, you can be careful, you can be systematic, and you can even have the power to find another way to prove that you have everything.